Hello, my name is Troy Cline. I'm from NASA's Goddard Space Flight Center, and I'm the director of something we call the STEM Innovation Lab. And this is a new concept that we've been working on for a few years now. And the idea is we want to take advantage of the maker movement, which is happening in the world, where communities of people and schools come together with pieces of technology that they can afford and acquire from different people. They bring it all into one space. And they invite the community or students or whoever wants to invent and tear things apart and learn into that space. It can be in a library, a classroom, a garage, someone's house, a basement, you name it, and you can create a makerspace. So we decided at NASA, wouldn't it be a great idea if we took the maker concept and we made one, a STEM Innovation Lab, on a NASA center. So at Goddard Space Flight Center, that's exactly what we did. And we created, starting about 2 to 3 years ago, a space where engineers and scientists and educators can come into that one room and explore education technology products from all over the place, including virtual reality, augmented reality, coding and electronics. We have 3D printers and paper cutters, and a variety of other technologies, including augmented reality, which is really a lot of fun. It's one of my favorite things to do. But what we also want to do is create a network of STEM innovation labs around the world. And we thought, why don't we make this as simple and easy as possible? So the general idea is that NASA STEM Innovation Lab works with scientists and engineers. They come into our lab and they look at 3D printers and they look at coding and electronics or Wi-Fi enabled lighting. And they give us ideas on how we can use that but with NASA content or space science content or earth science content. How can we take a 3D printer and create things that are beyond keychains and trinkets? Why don't we create some scientific instruments or parts for telescopes or something even greater? Drones that can fly up and capture data, or you can put sensors on these drones, or sensors in Coke cans, which we're going to see in just a little bit, something that is a small sensor that students have incredible ideas on how they can use it to actually help their community. So imagine taking a variety of small sensors that you can place on poles and put them all through your community to look at things like light pollution and look at things like air quality or even water quality, and bring all of that data together into one place, and students can decipher that data, analyze that data, and make a real impact and difference in their world. Well, where I'm standing right now is the Dikshant school in India. And with the innovative students and teachers and faculty here at this school, they decided after a conversation that a few of the representatives had, I guess it was maybe 3 or 4 years ago, at one of the World Maker Fairs in San Francisco. They talked with me there while I was presenting and talking about this really cool idea, came back to India and got the funding and created some think labs and think spaces in schools like this school. So where I'm standing right now is a type of STEM innovation lab that's very similar to the one that I work in. And over to my left, or to my right, you'll be able to see a drone section. And just a while ago, I had several students explain to me the different motors and the wiring and the programming that goes into creating drones. And why does that excite me? It's not because drones are new, it's because students are learning not only how they work, but how to fix them and become innovative and make them do things that we haven't even thought of yet. Now, as we walk around the room, you'll notice they have a series of robotics. It's just on one giant table across the room. You'll see all of the electronics and robotics pieces and parts that students can just put together and invent. Sometimes they make up their own ideas. Other times they take kits so they learn the process of how robotics works. So either way, we're giving the kids the power to invent on their own, which is the really important part. Now, as we walk around the room, we're going into an area that I kind of call the dirty area in my lab. We actually, in my lab, are wrestling with an issue because we have to have good and proper ventilation to be able to use laser cutters and soldering and all of it. And this particular room sounds like it feels like it's pretty ventilated so that they can get away with some of these things safely. But you'll notice we have soldering irons all over the place, and students can actually create their own circuitry and their parts as well, which is another important skill for them to have. And over to the far corner of the room, we have a lathe machine, which is really, really cool, not because of the technology they're using or the tools they're using, but because of what they're inventing. And at this school, they decided to use bamboo and LED lights and inexpensive materials to be able to take out into the community for really inexpensive and cheap and good lighting that people who can't afford all of the lighting that we have to have that's available can basically have this type of lighting for very inexpensive uses and materials that they can gather and get on their own. And the students here had that idea, and they're actually starting to put it out to the community. You can notice on the hand tools, which is one of the biggest important parts of any makerspace, we have to make sure we have all the tools available at their fingertips so they don't have to go searching. And the best way to do that is, instead of giant toolboxes where you have to dig through and look for things, you just basically look at the wall. And one idea I was sharing with them today is you can label where all the tools go. Some makerspaces basically paint the shape of the actual tool that goes on the wall. So when you take it off, you'll see the shape of this tool, and I know without having to read or do anything or think, that's where that tool belongs. So everything has its place and cubby. And one of the things you have to be really careful about in a makerspace is when students or the community come in, the place will be a disaster of activity, which is what you want it to be. You want pieces and parts to be everywhere so people are inventing and being involved. But when they're finished, you want it to be able to be cleaned up really quick. So everything has to have its place and identified around the room and in your facility for proper storage and safely put things away. So one of the last things that I really enjoy about these makerspaces and these labs, especially the one here in the school, is right behind me is a simple way to showcase all the work that the students are doing. In my lab at Goddard Space Flight Center, we have two shelves very much like this. So projects that are happening that are really cool that might invite people to think of their own ideas are on display all the time. And it constantly is moving. Things are being taken in and placed back on the shelves depending on what's actually happening in the lab. It's a quick shot, a good way to get support from your community. If they come in for a quick tour and they don't have time to really look around the lab, they can look at the shelf and see what you're doing in the lab in just a real quick jiffy. And the last thing, every makerspace that I've been part of so far has at least had one 3D printer. And what's nice about that is 3D printers are now very inexpensive. And you can get 3D printers anywhere from $60 to several $1,000s. The ones we use in our lab range anywhere from about $200 up to about $2,000, depending on what type of printer that you want. But you can get a really nice, inexpensive printer that will work for you really well. There are several varieties that you can use. The only advice I would say when you're choosing a 3D printer, you look it up and make sure that the reviews say that it's reliable and that the extruder head, which is where all of the melted plastic comes down and creates all of the different objects that you see inside. If the extruder head where the hot plastic comes out gets clogged up all the time, it renders it ineffective and you're spending all of your time trying to fix it. So there are many printers out there that are incredible for that and they don't get clogged up. There are many more ideas that I can share with you right now about the types of things that we can do in these types of STEM innovation labs and these think spaces. And one of the things that we're doing right now to help people who are starting their own lab is at the NASA STEM Innovation Lab website, we're uploading something that we call exploration idea profiles. Now these are basically just simple forms that we fill out that says what is the idea, who's involved, what's the impact, what materials are needed, and what are your extended ideas, who to contact for more information. And that's all it is. So that way anybody can go to our website, check out an exploration idea profile. There are 26 projects now of a variety of types. Everything from 3D printing to coding and electronics to virtual reality. And if you go there, you can find a project you might be interested in. And we don't want you to do exactly the project we did. We want you to take our exploration idea profile and make something with the idea that's your own. Become innovative, think outside of the box, create something really cool that you can showcase as your own work. And then I think you become a true maker. So we'd like to invite you to, if you haven't already started this in your school, please consider creating a makerspace and a think lab for your school, because I think that's going to change the world. We're giving our kids the opportunity and the tools they need to make a real difference.